So I want to start by thanking Jan and Maritza Vilcek for including me as an active part of tonight's festivities, because this event, this dinner, the reception, and the recipients of tonight are among my favorites. And it's therefore a special privilege to be here and to introduce the awardees to you. But I first want to say a few words about Jan and Maritza themselves and their vision for this foundation, because it actually has an interesting intersection with the scientific issues we will discuss in a minute. As you know, Jan and Maritza came to this country as escapees from communist Czechoslovakia with nothing but their intelligence, their grit, their training in art history for Maritza and in the biological sciences for Jan. And Jan became an immunologist at NYU, where he made a discovery that changed the treatment of autoimmune diseases and also changed somewhat the financial aspect of their life, hence the Vilcek Foundation. With exemplary generosity, Jan and Maritza decided to shine their warm light on others who, like them, had come to this country as immigrants and excelled in the arts and biomedical sciences. And tonight we will first honor 3 young biomedical scientists with the Prize of Creative Promise, and I will get to these remarkable individuals in a minute. We will also honor 2, let's say, more mature biomedical scientists who, like Jan, are immunologists. This is the first time that the Vilcek Prize goes to immunology, and I want to take a minute to point out what I think is an interesting parallel between what immunologists study, our immune system, and the system confronted by every immigrant, every permanent resident, every H1 or J1 visa holder who, like Jan did, comes to this country to study, to do research, and to make discoveries with the potential to cure diseases. In my view, our U.S. Immigration and Naturalization Service, our border control, our customs control, our sniffing dogs at the airport are all nothing less than our national immune system. Our immune system constantly is on the lookout for unwanted invaders. Like the officers with their sniffing dogs, it uses B-cell agents with immunoglobulins to find bad molecules in our blood. Like what happens at the airport arrivals hall, every invader, every bacterial cell coming into our body is scrutinized. Cellular officers of the immune system take the invader's fingerprint, take its picture, and this impression is compared with vast databases embedded in the memory of our immune system to see whether the invader belongs to us, has a record, is bad or is good. And like what happens when we drag our bags tired through customs control, our own cells are checked for what is in their luggage. Are they carrying something illegal, something dangerous, maybe a parasite, a virus? All this is done by our immune system without much debate, without fanfare, and most of the time without blocking useful invaders and without turning on ourselves. If this were only true for our country's system that regulates immigration, perhaps we should send tonight's awardees or other immunologists to Washington to explain to our policymakers how to set up a system to deal with immigrants. But let's now first turn to the promise for the future of biomedical sciences, which is surely in the hands of the 3 individuals selected for the coveted Vilcek Prize for Creative Promise in Biomedical Sciences. They have come to this country from far-flung places. Hashim Al-Hashimi was born in Lebanon, but he found himself in Iraq and was living in Iraq as an Iraqi citizen when Saddam Hussein decided to invade Kuwait. Because he was at risk of being drafted at the young age of 16, he fled very quickly to the UK, where he obtained training in chemistry and then came to the US to do his PhD and postdoctoral training, in fact, here in New York. He now runs his own lab at the University of Michigan, where he's incredibly successful in determining the structure of DNA and RNA molecules that are important for human disease. Michael Rape originally hails from Germany, where he began his studies on ubiquitin with Stefan Jentsch at the Max Planck Institute and Martinsried. Ubiquitin is a small molecule that is added to many proteins to change their destiny and function. Rape has remained remarkably faithful to this subject and studied ubiquitination as a postdoc at Harvard and now at UC Berkeley, where he heads his own lab, which is highly successful. And a third prize winner, Joanna Wysocka, now at Stanford, studying the intersection between early development and chromatin modification, is originally from Poland, where she was a teenager when the Berlin Wall came down, allowing her to do a summer internship at Cold Spring Harbor Laboratory on Long Island, where she was first introduced to U.S. biological sciences. And this led her to decide to seek training in this country, and she never returned. All three of these young scientists were selected because they've been startlingly successful at a very early stage in their career. And there's every indication that they will become leaders in science in the future.